The year was 1940, and Europe was burning. Donald Roebling sat in his Florida workshop, surrounded by strange contraptions and half-built machines. When the letter arrived, it was from the U.S. Marine Corps, and it contained a request that would change warfare forever. But at that moment, Donald had no idea that his bizarre invention, something the military had initially laughed at, would become one of the most critical weapons of World War II. To understand why this matters, you need to picture what was happening across the Atlantic. German panzer tanks were rolling through Europe like an unstoppable steel tsunami. They had conquered Poland in weeks, shattered France in days, and were now setting their sights on the rest of the world. The secret to their success wasn't just the tanks themselves, it was their ability to move them anywhere, anytime, across any terrain. But there was one obstacle that stopped even the mighty German war machine: cold, water, rivers, canals, lakes, coastlines. Tanks, you see, have a fatal flaw. These multi-ton beasts of steel and firepower sink like stones the moment they touch water. And Europe, especially the territory the Allies needed to reclaim, was crisscrossed with thousands of rivers and waterways. Every single one became a natural fortress for the enemy. The military engineers had solutions, of course: pontoon bridges, temporary spans. But here's the nightmare scenario that kept generals awake at night. Building a bridge takes time. Hours. Sometimes days. And during every second of construction, your soldiers are sitting ducks. Enemy artillery rains down. Mortars explode. Machine gun fire tears through your engineers as they frantically bolt together bridge sections. The casualty rates were catastrophic. But there was an even worse problem looming on the horizon, one that made the river crossings of Europe look like child's play: the Pacific Theater. Imagine this: thousands of small islands scattered across an endless ocean, each one fortified by Japanese soldiers who had months, sometimes years, to dig in and prepare. Each island surrounded by coral reefs that could rip the bottom out of any landing craft. And between the ocean and the beach, a killing zone of sand, water, and withering gunfire. The U.S. military ran simulation after simulation. Every single one ended the same way: catastrophic losses. Thousands of young men cut down before they even reached the beach. The admirals and generals gathered in smoke-filled rooms in Washington, staring at maps, knowing that the current technology would turn every Pacific Island invasion into a bloodbath. They needed something that didn't exist. They needed a vehicle that could carry troops and equipment through ocean waves, climb onto hostile beaches under heavy fire, then continue inland like a tank. It had to be fast, armored, and carry dozens of soldiers. It had to be, in essence, a boat that could become a tank, or a tank that could swim. When engineers heard this requirement, they laughed. Some said it was physically impossible. Others said that even if you could build such a thing, it would be so slow and unwieldy that it would be useless in combat. But then someone remembered Donald Roebling. Now, Donald was not a military man. He was an eccentric millionaire inventor with a peculiar hobby. He built vehicles that could travel through the Florida Everglades. You see, Donald had a soft spot for people in trouble, and he'd read about a devastating hurricane that had killed hundreds of people in the Everglades in 1926. Rescue workers couldn't reach the victims because their boats got stuck in the shallow marshes and their trucks sank into the swamp. So Donald, being Donald, decided to invent something that could handle both land and water. What he created looked absolutely insane. Like someone had welded a boat hull onto a tractor. It had treads like a tank, but it floated. It could crawl through swamps, swim across lakes, and drive on land. He called it the Alligator, and it was designed for one simple purpose: rescuing people from swamps. The military had actually heard about Donald's Alligator years earlier. In 1937, they'd sent representatives to Florida to see if this swamp buggy could be useful. They watched it paddle around in circles, slow and awkward, and dismissed it entirely. Too slow, too fragile, useless for war. But now, 3 years later, with the world at war and invasion plans that required the impossible, someone in the Marine Corps had a desperate thought. What if we were wrong about the alligator? What if that crazy swamp vehicle could be modified? That's when the letter arrived at Donald Roebling's workshop. The letter was polite but urgent. Would Mr. Roebling be willing to revisit his design? Could the alligator be made faster, stronger, armored? Could it carry troops? Could it survive combat? Donald read the letter twice, set it down, and looked around his workshop at his peaceful swamp rescue vehicle. He thought about the young men who would die on distant beaches if someone didn't solve this problem. And he made a decision that would save countless thousands of lives. "Let's find out," he said to himself, rolling up his sleeves. What Donald Roebling didn't know, what nobody could have predicted, was that he was about to invent one of the most important vehicles in military history. A vehicle that would storm the beaches at Guadalcanal, Tarawa, Iwo Jima, and Okinawa. A vehicle that would cross the rivers of Europe and break through enemy lines. A vehicle that would serve in Korea, Vietnam, and conflicts for generations to come. But first, he had to solve about 100 problems that expert military engineers said couldn't be solved. The clock was ticking. Young men were training for invasions that would send them into the meat grinder. And in his Florida workshop, a civilian with no military training was about to prove that sometimes the impossible just needs someone crazy enough to try. Donald Roebling had exactly 6 months to do what military engineers said would take years. 6 months to turn a peaceful swamp rescue vehicle into a combat-ready amphibious assault vehicle that could withstand machine gun fire, carry 30 fully equipped Marines, cross ocean waves, and storm enemy beaches at speeds that wouldn't get everyone killed. No pressure. The Marine Corps gave him a list of requirements that seemed designed to prove the project was hopeless. The vehicle needed to travel at 12 miles per hour in water 4 times faster than his original Alligator. It needed to carry 4 tons of cargo. It needed armor plating that could stop rifle bullets. It needed to operate in salt water, fresh water, and on land without breaking down. And here's the part that made even Donald gulp. It needed to do all of this while navigating through coral reefs that could tear apart ship hulls, in waves that could flip boats, under enemy fire that would be concentrated on every square inch of beach. Donald's team got to work immediately, but they quickly discovered that every solution created 3 new problems. Make the vehicle faster in water? The added power made it unstable on land. Add armor plating? Now it was too heavy to float. Strengthen the treads for beach assault? They became too rigid for swamp navigation. It was like trying to design something that was simultaneously a speedboat, a tank, and a truck, each requirement fighting against the others. But then Donald had his first breakthrough, and it came from an unlikely source: alligators. Real ones. He'd spent years watching how alligators moved through the Everglades, transitioning seamlessly from water to land. Their tails propelled them through water. Their legs powered them on land. But the real secret was their body shape streamlined enough to swim, but with enough belly clearance to climb over obstacles. Donald redesigned the hull with a boat-like shape that could cut through water, but he added a clever twist. The tracks extended all the way around the vehicle, creating propulsion in water, while also pulling the craft up and over obstacles on land. The treads essentially became both wheels and propellers. The Marines sent Lieutenant Colonel Victor Krulak to Florida to oversee the project. Krulak was a hard man who'd seen combat and had no patience for inventions that looked good on paper but failed in reality. He arrived expecting to find a civilian playing with toys in a workshop. What he found instead shocked him. Donald's new prototype, now called the LVT-1, Landing Vehicle Tract, looked like something from a science fiction novel. It was boxy and strange, with tracks that seemed too big for the body, and a hull that didn't quite look like a boat or a tank. But when they fired up the engine and drove it into the water, something miraculous happened. It worked. The vehicle glided into a lake, its tracks churning water, propelling it forward at a respectable speed. Then, without stopping, it climbed up the muddy bank and continued onto dry land, tracks gripping the earth, moving at nearly 20 miles per hour. Krulak watched in silence as the LVT-1 splashed back into the water, turned in a tight circle, and returned to shore. "Do that again," Krulak said quietly. They did it again. And again. And again. After the 10th demonstration, Krulak walked up to Donald Roebling, stuck out his hand, and said 4 words that would change everything. "This will save lives." But the Marine Corps brass still wasn't convinced. They needed to see it perform under real conditions. So, in May 1941, 7 months before Pearl Harbor would drag America into the war, they organized a demonstration that would either prove the LVT was a revolutionary war machine or an expensive failure. The test site was Culebra, a small island off Puerto Rico, and the Marines set up conditions that mimicked a hostile beach landing. They had troops firing machine guns at the vehicle. They made it navigate through actual coral reefs. They loaded it with 30 Marines in full combat gear and made it drive through 4-foot ocean swells. This is where things got dramatic. On the first run, the LVT-1 hit a coral reef and one of the tracks jammed. Water started pouring into the vehicle. The Marines aboard thought they were going to sink and drown in full gear. But Donald had anticipated this. He designed the vehicle with enough buoyancy compartments that even with flooding, it stayed afloat. The crew cleared the jam and continued to shore. The generals watching from the beach were furious. "This is exactly what we were afraid of," one shouted. "It's too fragile for combat." But Lieutenant Colonel Krulak saw something different. "In combat," he said coldly, "that vehicle would have been hit by enemy fire long before it reached that reef. The fact that it survived the damage and kept going, that's what matters." They ran the test again. This time, the LVT-1 navigated the reef successfully, climbed onto the beach, while Marines fired blanks to simulate combat conditions, and deposited its troops safely inland. The whole operation took less than 10 minutes, compared to the hours it would take to build a bridge or the catastrophic casualties of a traditional beach landing. The watching generals fell silent. One of them finally spoke. "How many of these can you build, and how fast?" Donald did some quick mental math. With proper funding and facilities, maybe 200 by year's end. "Not good enough." The general replied, "We need thousands. We need them now." And here's where the story takes a shocking turn that reveals just how close the United States came to losing the Pacific War before it even started. Pearl Harbor was attacked on the 7th of December, 1941. At that moment, the United States had exactly 200 LVT-1 second in existence. Just 200 amphibious vehicles to fight a war across thousands of Pacific islands. The military immediately placed orders for thousands more, but there was a devastating problem. Nobody knew how to mass produce them. Donald's workshop in Florida could build maybe 5 a month. The country needed hundreds every month. Desperate, the military turned to an unlikely source. The Food Machinery Corporation, a company that built farm equipment and food processing machinery. They'd never built a military vehicle in their lives. But they had factories, engineers, and most importantly, they knew how to build things quickly and cheaply. The FMC engineers took one look at Donald's design and said it was too complex to mass produce. Too many custom parts. Too many things that had to be hand-fitted. If they were going to build thousands of these vehicles, they needed to completely redesign it for assembly line production. Donald was horrified. "You'll ruin it," he protested. "Every modification I made was essential." But the clock was ticking. Young Marines were already training for the first island invasions, and they were training with equipment that didn't exist yet. The military made a brutal decision. They gave FMC permission to modify the design however necessary to achieve mass production. What happened next was a masterclass in wartime innovation. And it came with some terrifying near disasters. The redesigned LVT-2 rolled off the first assembly line in January 1942. It looked similar to Donald's original, but dozens of components had been simplified or replaced. The military rushed them to the Pacific for the first major amphibious assault, Guadalcanal. And that's where everything almost fell apart. The 7th of August, 1942, Guadalcanal. The first wave of LVTs hit the water at dawn, carrying Marines toward a beach that Japanese forces had been fortifying for months. This was it, the moment that would prove whether Donald Roebling's impossible idea would save lives or become a floating coffin for American soldiers. The Marines had trained with the LVTs for barely 3 weeks. Most of them had never seen an amphibious vehicle before in their lives. Now they were packed inside these strange machines, 30 men per vehicle, listening to the deafening roar of engines and the splashing of treads through ocean water, wondering if they'd make it to the beach alive. Then the Japanese opened fire. Machine gun bullets pinged off the armored hulls. Mortar shells exploded in the water, sending up geysers that rocked the LVTs. And the vehicles kept coming. They climbed over coral reefs that would have shredded traditional landing craft. They pushed through surf that would have swamped smaller boats. And then, in a moment that left observers speechless, they drove right out of the ocean and onto the beach without stopping. The Marines poured out of the LVTs and immediately began taking ground. Traditional landing craft were still offshore, trying to navigate the reefs, their troops wading through chest-deep water under heavy fire. But the LVT Marines were already inland, moving fast, because they'd arrived dry, organized, and ready to fight. The initial reports sent back to headquarters were euphoric. The LVTs had worked beyond anyone's wildest expectations. They'd crossed terrain that military experts said was impassable. They'd survived combat conditions that should have destroyed them. The amphibious assault vehicle had just revolutionized warfare. But then, 3 days into the operation, Marines started dying in ways that made no sense. LVTs were exploding from single bullet hits. Not artillery shells or grenades, ordinary rifle bullets were somehow causing catastrophic explosions that killed everyone inside. Vehicles that had survived the initial beach assault were suddenly becoming death traps in routine operations. The military launched an immediate investigation, and what they discovered was horrifying. In the rush to mass-produce the vehicles, the manufacturer had made a seemingly minor modification. They'd moved the fuel tanks. In Donald's original design, the fuel tanks were positioned low and protected, but to simplify assembly, the redesigned LVT-2 had fuel tanks mounted higher and closer to the crew compartment. A single tracer round a bullet designed to leave a visible trail could puncture the tank and ignite the gasoline. The result was instant incineration. Marines were being burned alive inside vehicles that were supposed to protect them. Back in the United States, Donald Roebling was devastated when he heard the news. The vehicle he designed to save lives was killing the very men it was meant to protect. He'd warned them not to modify his design. He'd told them every detail mattered. But in the rush to win the war, corners had been cut, and now young men were paying the price. The military faced a nightmare scenario. They had hundreds of LVTs in the Pacific and thousands more in production, all with the same fatal flaw. Recalling them would cripple the entire Pacific campaign. Soldiers would die on beaches while waiting for redesigned vehicles. But leaving them as they were meant more Marines would burn to death. They made a brutal calculation. Fix the vehicles in the field, even though it would take weeks and leave units vulnerable. Immediately halt production and redesign the fuel system. And most controversially, continue using the flawed vehicles in combat because even with the risk, they were still safer than traditional beach landings. Field engineers worked around the clock, welding additional armor around fuel tanks, relocating fuel lines, adding fire suppression systems. It was dangerous. Improvised work modifying combat vehicles while under enemy fire. But slowly, the LVTs became safer. Meanwhile, the redesigned LVT-3 was already on drawing boards, incorporating Donald's original safety features plus new innovations learned from combat. But it wouldn't be ready for months. And the military had already planned the next major operation, Tarawa. If Guadalcanal had been a test, Tarawa was going to be hell. The 20th of November, 1943. Tarawa Atoll. Betio Island was less than 3 square miles, but the Japanese had turned it into the most heavily fortified position in the Pacific. Thousands of troops, hundreds of concrete bunkers, thousands of mines, and artillery positions that could hit anything that came near the beach. Intelligence estimated it would take 3 days of heavy fighting to capture the island with casualties in the thousands. The Marines had one advantage. They had the new LVT-2 seconds with the redesigned fuel systems. Plus, something revolutionary: armored LVTs, equipped with actual weapons. Some carried machine guns. Others had been modified to carry light artillery. These armored Amtraks could provide covering fire while delivering troops. The plan was simple in concept, terrifying in execution. Send the LVTs directly into the teeth of Japanese defenses, land on the beach under fire, and establish a beachhead before the enemy could react. At dawn, 125 LVTs entered the water and began the run to shore. Japanese artillery opened up immediately. The ocean erupted in explosions. Several LVTs took direct hits and sank, taking their crews with them. But the rest kept coming. Here's what happened next, and it's one of the most dramatic moments in Marine Corps history. The LVTs hit the beach in waves, their tracks chewing up sand, their weapons returning fire at the Japanese bunkers. Marines poured out and immediately came under devastating fire. But then something unexpected happened. The LVTs didn't leave. In previous amphibious assaults, landing craft would drop off troops and retreat. The soldiers were on their own, but the LVT commanders made a split-second decision that wasn't in any manual. They stayed on the beach and fought. The armored LVTs became mobile bunkers, providing cover for the Marines. They used their machine guns to suppress enemy positions. They carried wounded men back to the water and brought fresh troops and ammunition forward. They even pushed through enemy defenses to deliver supplies directly to cut-off units. The battle was brutal. 3 days of close-quarters combat. More than 1,000 Marines killed. Thousands more wounded. But military analysts later concluded that without the LVTs, the casualties would have been double or triple. Maybe the assault would have failed entirely. And here's the shocking part that most people don't know. While the battle for Tarawa was raging, back in Europe, American forces were facing their own water-crossing nightmare. The rivers of France and Germany were becoming impassable barriers. Traditional bridges were destroyed. Pontoon bridges took too long to build. Thousands of soldiers were stalled, unable to advance. Someone in the European command had a radical idea. What if we sent LVTs to Europe? The idea seemed crazy. The LVTs were designed for Pacific Island assaults, not European river crossings. But desperate times called for desperate measures. In early 1944, a shipment of LVTs was sent to Europe for testing on the Rhine River approaches. The results shocked everyone. These vehicles, designed to cross coral reefs and storm beaches, turned out to be perfect for river crossings. They could carry troops and supplies across rivers in minutes instead of hours. They could operate in conditions that would sink traditional boats. And because they could drive onto land without stopping, they could establish bridgeheads faster than any other method. During the crossing of the Rhine in 1945, one of the most critical operations of the European War, LVTs ferried thousands of troops and tons of supplies across the river while under enemy fire. Bridges that would have taken days to build were suddenly unnecessary. The vehicles that were supposed to island hop across the Pacific were now punching through the heart of Germany. Donald Roebling's impossible swamp buggy was now winning the war on two fronts, 8,000 miles apart. But the story doesn't end there, because what happened to the LVT after the war reveals something profound about innovation, adaptation, and the strange way that solutions to one problem can solve dozens of others you never anticipated. When World War II ended in 1945, the military had produced over 18,000 LVTs. 18,000 vehicles that had stormed beaches from Guadalcanal to Okinawa, crossed rivers from the Rhine to the Elbe, and fundamentally changed how amphibious warfare was conducted. Most people assumed that was the end of the story. The war was over. These specialized vehicles would be mothballed, scrapped, or left to rust in military depots. After all, how often does a country need to storm enemy beaches or cross rivers under fire? But then something unexpected happened. something that would have made Donald Roebling smile. In 1946, a massive hurricane slammed into the Florida coast, the same region where Donald had first built his alligator to rescue people from swamps. Entire communities were cut off by flooding. Roads were underwater. Traditional rescue vehicles couldn't reach the stranded survivors. Someone remembered that there were dozens of surplus LVTs sitting in a nearby military depot. Within hours, these combat vehicles were repurposed as rescue vehicles, doing exactly what Donald had originally envisioned 20 years earlier. They churned through flooded streets, crossed submerged roads, and reached people that no other vehicle could access. In 3 days, LVTs rescued more than 2,000 people who would have otherwise died waiting for the waters to recede. News of this spread quickly. Fire departments wanted them. Coast Guard stations requested them. Civil defense organizations across the country realized that these war machines were actually the most effective disaster response vehicles ever created. But the military wasn't done with them either. The 25th of June 1950. North Korea invaded South Korea, and once again, American forces found themselves facing water obstacles. The Korean peninsula is covered with rivers, rice paddies, and coastline, and once again the LVTs proved invaluable. But here's where the story takes a fascinating turn. The Marines who'd used LVTs in World War II were now commanders, and they'd learned some unconventional lessons. They started using LVTs in ways that Donald Roebling never imagined. They used them as armored personnel carriers in urban warfare. They modified them into mobile command posts. They even used them as supply vehicles in areas where roads didn't exist. The LVT had evolved from a specialized beach assault vehicle into an all-purpose solution for moving troops and equipment in hostile territory. During the Incheon landing in September 1951, of the most daring amphibious operations in military history, LVTs once again proved decisive. The landing site had extreme tides that left traditional landing craft stranded on mudflats, but the LVTs simply drove across the mud, up and over the seawalls, and into the city. What should have been a logistical nightmare became a tactical triumph. Vietnam brought yet another evolution. The Mekong Delta's endless maze of rivers, canals, and rice paddies was impassable for most military vehicles. But LVTs, now redesigned and upgraded with more powerful engines and better armor, became workhorses of riverine operations. They transported troops through terrain that had no roads, no bridges, no dry land for miles. By this point, the original LVT design had spawned dozens of variations. Some were equipped with artillery. Others became recovery vehicles for disabled tanks. Some were fitted with anti-aircraft guns. The basic concept, a vehicle that could transition seamlessly between water and land, had proven so versatile that engineers kept finding new applications. But perhaps the most shocking legacy of the LVT is one that most people never hear about. It fundamentally changed how we think about disaster response. Remember, Donald Roebling's original inspiration was saving people from natural disasters. The military had co-opted his design for war. But after the war, it came full circle. Today, amphibious rescue vehicles based on Donald's original design are stationed around the world. When tsunamis hit, when floods devastate communities, when hurricanes submerge entire regions, amphibious rescue vehicles arrive and save lives. The technology has been refined, improved, and modernized. But the core concept remains the same. A vehicle that can go where nothing else can go. The Japanese self-defense forces use them for earthquake and tsunami response. European countries deploy them for flood rescue. The U.S. Coast Guard maintains fleets of amphibious vehicles for emergency response. All of them descendants of that strange swamp buggy that a civilian inventor built in his Florida workshop because he wanted to help people. Here's an astonishing fact that brings this full circle. In 2005, when Hurricane Katrina devastated New Orleans, one of the most effective rescue vehicles deployed was a direct descendant of Donald Roebling's LVT design. 70 years after Donald first sketched his idea, and 60 years after the military said it was impossible, his invention was still saving lives from the exact disaster that had originally inspired him. Donald Roebling lived to see his invention transform warfare and save countless lives. He died in 1959. but not before witnessing LVTs in action in both World War II and Korea. In interviews near the end of his life, reporters would ask him about his contribution to military history, about the thousands of Marines who survived beach landings because of his invention. His response was always the same: "I just wanted to help people stuck in swamps." But here's the deeper truth, the lesson that makes this story resonate far beyond military history. Donald Roebling wasn't trying to revolutionize warfare. He wasn't trying to solve an impossible military problem. He was trying to save people from hurricanes. The military looked at his solution and saw something he'd never intended: a way to storm enemy beaches. Then disaster responders looked at the military vehicle and saw something else: a way to rescue people from floods. Each group saw different possibilities in the same basic idea. This is the real legacy of the impossible idea. It's not just that Donald proved the experts wrong, or that his invention saved tens of thousands of lives in combat. It's that he demonstrated something profound about innovation. Sometimes the best solutions come from people who aren't experts in the field, who aren't constrained by what everyone knows is impossible. The military engineers who first saw Donald's alligator in 1937 dismissed it because they were thinking like military engineers. They saw its limitations. They saw why it wouldn't work. Donald, coming from outside their world, saw only possibilities. He saw what it could become, not what it currently was. Today, every military in the world has some form of amphibious assault vehicle. The U.S. Marines currently use the AAV-7, a direct descendant of Donald's LVT, and they're developing even more advanced versions. These modern vehicles can reach speeds of 40 miles per hour on land and 8 miles per hour in water. They're armored against heavy weapons. They can carry 25 troops plus crew. They can operate in conditions that would destroy any other vehicle. But trace the lineage back, and you find yourself in a Florida workshop in 1935 with a civilian inventor building a strange contraption to rescue people from swamps, while military experts around the world were absolutely certain that what he was attempting was impossible. The ultimate irony? Donald Roebling never made a profit from his invention. He donated his patents to the government. He refused payment beyond his basic expenses. When asked why, he said simply, "Men are dying. If this helps, that's payment enough." So the next time someone tells you something is impossible, remember Donald Roebling. Remember that a swamp rescue vehicle became a war-winning weapon. Remember that sometimes the impossible just needs someone who doesn't know it can't be done. And remember that one person's impossible idea saved tens of thousands of lives in war and continues saving lives in peace more than 80 years later. Because in the end, Donald Roebling didn't just build a vehicle that could cross rivers without bridges. He proved that civilian innovation can solve military problems, that peaceful inventions can win wars, and that the most impossible ideas are sometimes the ones the world needs most. The alligator that became a war machine, that became a rescue vehicle, that changed the world. That's the legacy of the impossible.